It just comes out like 26 now. Win state.
All right, look at problem 4 on this. We're going to do problem 4 the long way, then we'll do one of them on the back, punch it into the calculator, make sure you understand that. So when you're doing this, when you're doing that using the chart, and you will have to use the charts later on in the year, so know the parts, because we're going to add other parts to it to come up with other stuff as the year goes along. What was our columns? We had our X.
X minus
Bar X, X bar,
and then
or mu, whichever one it happens to be.
and then just square that. Same thing, just in parentheses. You square.
So we got to find each one of these. Let's see if we do number 4. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15 of them. Is that right?
Yeah, 15.
One, two, three. I'm not gonna count them. Somebody help me out and read off the list to me. Are they in order?
Yeah, 54, 55, 56, 57, 59, 60, 63, 68, 78, 80, 81, 83, 94, 95, and 96.
All right, first thing we need to do, add all those up. So grab your calculators out, add them all up, and we're going to divide by 15 so that we can find the X bar. That's X bar. While you're doing that, I'll try to make my screen a little better here. We do have a test coming up over chapter 2, so be,
Next class?
probably not next class, but real soon.
You going to beat us in basketball again?
Huh?
So you're going to beat us in basketball again?
I don't know if we'll do that again. That wasn't much fun for me. It was too easy.
Yeah, 'cause you got lost.
71.93 repeat.
What was the total?
How did you type that in?
1,079.
You did do that.
You said 71 point,
93 repeat.
let's just go 71.9, that's close enough. Now we're going to take each of our X's, each of our actual pieces of data, and subtract off the X bar, the mean. So help me out with 71.9, or I'm sorry, what's 54 minus 71.9?
Negative 17.9.
Next one's negative. I'm gonna try not to mess this one up this time.
16.9.
And that probably means the next one's gonna be negative 15.9, right?
Yeah.
And negative 14.9. If I mess something up, somebody please tell me before we get too far.
And that's 12. 11. 8.9. Negative 8.9. That'd be negative 3.9.
Then we're gonna be on the positive side.
Yeah, 6.1.
8.1, is that right?
Yeah.
You guys are all telling me we should just take a quiz over this today?
No.
That's what what it seems like to me. What's that, 11.1? About 94 minus that.
22.
What is it?
22.
22.
23.
Now, what are we gonna do with all those? First of all those should total up to how much?
0.
Should total up to 0. Hopefully it does. You don't have to total them up, but just hopefully it totals up to 0. What do we do with each one of those?
Square.
Square. Now, again, try to make it easier on you. This column, I don't care if you really fill in this column, but as we tried to do this the other day, we figured out that if we don't fill in that column, stuff's pretty screwed up and everybody gets different answers and everything else. So you might want to fill in that column, but if I was doing it, I would just take this number, square it, plus this number squared, plus this number squared, and I would punch all of that into my calculator as one thing and just come up with the sum, because that sum's what we need. All right? So go through and try to do that on your calculator. We'll see if we can come up with more than one person. Again, do you need to put in the negatives on these?
No, do the same thing.
If you're squaring it, it's going to end up being a positive anyway, so no reason. So just, all you're going to put into your calculator is you're going to do 17.9 squared plus 16.9 squared plus, and just keep going. All of those. We want that total. And hopefully we can get more than one person all have the same answer. You got the same answer? That's better than last class, I think,
Man.
because
I was lost.
there was like 75 different answers and there was only like 10 of you.
Yeah, they kept doing it different numbers.
I'm not gonna try that.
Do what?
What'd you get?
I didn't do it. I'm counting on you guys.
3,394.95.
Is that what we're going with? What is it? 3,394.95. Is everybody getting that?
Yeah.
Gotta be careful when you punch it into the calculator, right? Nothing else, all this stuff. Even if we put it in as a list, which we're gonna do here in a minute, still gotta be careful. Remember this, that's the sum of the squares. All right? Once we have that, most of the time, again, the stuff that they'll want us to find, X bar, which we already found, which was 71.9. So that's probably one of our answers. I don't even remember what all did the paper ask you to find.
Mean, median, variance, and standard deviation.
So 4 things. So this is our mean, median. We can come over here. How many numbers were in our list?
15.
So again, if you wanted to do it this way, 1, 2, 2, 3, 3. The only bad thing is Michael gets distracted easy, so now he forgets where he was at on the list. And if there's 15 of them, what's half of 15? if we go to the whole number 7, 1, 2, 3, 4, 5, 6, 7. So that's the 7th one from the top. 1, 2, 3, 4, 5, 6, 7. 7th one from the bottom. What's our median going to be?
68.
68.
That's one of our answers. Now to find the variance and the standard deviation, we use this number that you guys calculated. The variance, remember variance is S squared. We take our number, 3,394.95, and we divide it by, be careful with this, each of these, they said on the sheet, was a sample. So what do we divide this by? N minus 1, what is N this time?
15.
15, and you know, if you wanted to write that down somewhere, N equals 15, that's an ugly N. N equals 15. So 15 minus 1, what's that give us?
2 minus 1.
We get 14.
14, so then what?
It's 242.46.
496.
242 point what?
Did I do something?
464.
464, anybody else get that? Let's make sure.
You got 33.
242. Everybody divide it again, because again, if we get different answers.
I just got the decimal wrong. I got the 242 right.
Oh, divide it again, see, maybe yours is right.
I got 0.46.
4.6,
3394, right?
so we'll just say 0.5, that's close enough.
3394.5.
Say,
14.
oh, you're telling him what's it for.
242.496.
So 242.5,
That's
Yeah.
right.
all right, so that's our variance. How do we find the standard deviation, which is just S? Take the square root of that. So take the square root of 242.5.
It's 15.57.
15.57,
Yeah.
so we'll say 15.6. That's our standard deviation. Remember the standard deviation, if we were going to draw our a little chart out here, and we're going to go into this more today, standard deviation, on our little graph, we put our median, or not our median, put our mean right in the middle, 71.9. We usually go out 3 standard deviations on each side. So it'd be 15.6, here we add 15.6. What is that? That's 15.6 plus that is 87.5. If I do something wrong, somebody please tell me. Add another 15.6, that's 103.1, I think.
Yeah.
And then add another 15.6, that'd be 118.7. Well, I can't do this one, I don't think. Subtract 15.6, that'd be 71.9 minus 15.6. Somebody help me out.
56.3.
Subtract off another 15.6,
40.7.
40.7,
Yeah.
and subtract off another 15.6.
25.1.
So if we have this graph, this is our mean. Again, this is key for stuff we're gonna do as stuff gets harder throughout the year. It's key that you understand this graph. If this is a symmetric graph or if it fits that bell curve, then we know that from here to here is 34% of all the data. From here to here, 34% of all the data. Should fall in those 2 ranges. This one, 13.5% or 13.5%. From here to here, 13.5%. And then these last two, we'll say about 2.5. We'll just round it off somewhere close. About 2.5% there, 2.5% there.
Is that the bell curve we talked about last time?
Yep. This is the bell curve, or the empirical rule. Empirical rule. So that's the empirical rule. Now, whether this fits the empirical rule or not, I don't know. We can find out by looking at this and saying, if we pick like these two right here, let's just pick these two together. That should be about 68%. We're between 56.3 and 87.5. So if I look over here at our numbers, 56.3, so that's going to start here at 57. That should fall in there. Up to 87.5, so up to 87.5, that's going to be 83 is going to be the last one we include. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Somebody help me out. We got 9 out of 15. What percentage do we have?
60%.
About 60%. That's not too far off of that. So with this small set of data, only 15 numbers, it very well could fit the bell curve. Let's try another one. Let's see. 103 to 118. How many numbers we got that falls in there?
0.
0. Let's go down here. 25 to 40. How many numbers?
0.
0. So that doesn't really help us because those are way out there. Let's go 40.7 to 56. So 3 divided by 15, what's that give us?
It'd be 20%.
20%. So about 20% falls in here. You just divide it backwards. So that's about 20% there. Let's look at this one over here. 87.5 to 103. That's going to be 3 out of it, so that's going to be about 20%. So our graph is actually this way. There's 60% here, 20% here, 20% there. Is that sort of going to fit that bell curve?
It's close.
Yeah, it's close. It's probably just that we have so few in numbers. We only got 15 numbers. Maybe if we had more, it would better fit the bell curve, but it looks like it's going to be close. Looks like it's going to be sort of symmetric. Oops, wrong way. On the back, problem number 5. What I want to do with problem number 5, take your calculator, and we're going to put all those numbers into a list on the calculator. So, does everybody remember how to put them into a list?
Stats.
Go to Stat, good. Edit, and you can put it in list 1, list 2, whichever list you want to put it in. Just make sure that you might have to delete some numbers out of your list. If I can find the delete button on my
I can't find the stat. I'm on that, so no.
stats on the
Do you see the alpha?
top, sort of right where the arrows are.
Like go to the alpha and then flip over.
Making fun of Jay.
Got it.
That's funny.
So try to type those in, all of them for number 5.
I
Type
got
them
mine
into a
typed in.
list.
And I would change it since you put it in there.
I know none of you actually want to use the calculator, you'd rather just make the big charts, right?
Yep. Oh, I just put this in 145. How many is there? Did you read the basketball email? We have 12 girls.
12?
Yep.
Who all is it?
7 of them are. Did he put her in? No way.
Wait, who all is it?
Jenna, Skylar, me,
But here's the thing, they're not
Jada.
gonna have a team next year, cause
What's our seniors? And then Maddie, Micaiah, Ashlyn, Sam, Caitlin,
Who's Kate?
Natalie, Josie,
we might have a JV team.
and then
that's
scroll
next
here.
year's.
Or 2 quarters of JV.
We have a lot.
Right, so you have like 20 something.
Like 22.
We just have no underclass.
How many numbers were there?
30.
30.
That's a lot.
And I'm gonna send out a basketball shirt design.
Last year you guys only
We
had
have
17,
They're like 7 varsity.
That's not
like
bad.
7 full-time.
Yeah, but it was rough.
The stuff that we do today, we'll talk about it, a little foreshadowing, we'll talk about it
We have like 8
with this. Once you have them all punched in there, hopefully you punched them all in correctly and you get the same thing that we get. Go back to stat,
Bless you.
scroll over to calculate. So push the stat button again, then go to calculate. We want the very first one, which is 1 variable stats. Later on in the year, you see where it says 2 variable stats. That's where you got 2 different lists and you're putting them together. We'll do that. So go to 1 variable stats, hit enter. On your screen, it'll pop up 1 var stats, and then you got to hit second, and whichever list you put it in. I put mine in list 1, so I just hit second, then the number 1. If you put it in a different list, then you put in that list. Then you hit enter.
Ooh. Did you not get what we got?
And it tells you all kinds of stuff. What's the first thing it tells you?
The X bar.
X bar, that's the mean, right? What's the X bar?
101.9.
We'll say 101.9, that's close enough.
That's pretty hard.
Now notice, it also tells you this. We added them all up a few minutes ago on the other problem on our own. That's just telling you what all the X's, all the data adds up to. Next thing, this is what we're going to do as we go on. This is going to be important. We haven't talked about it yet, but in our chart, we got our X, we got our X minus our X bar, we got that squared. Some of the other columns on out here that we're going to add on to it, one of them is going to be this, X squared. And this time X squared is 339,192.
So it's that total just squared.
Right, so it just, when we get to this,
That's close.
it's all the X squared.
Just add it up.
You just take each one and you square it, and then you add them all up. That's the answer it would be. Then if we go on down, you got this S with a little subscript X. That's supposed to be a subscript. And it says 30.27, we'll say. That's our standard deviation. That's our standard deviation for our worksheet because we were dealing with a what?
Same
sample. If they had told us that that was the entire population, then the next one, the sigma with the little x, which is 30 point, did I write the wrong one? I did, didn't I? Heck, on it.
So what are we
Why
gonna
didn't
say?
somebody tell me that? This should be 30.78, shouldn't it?
Yeah.
I should scare ourselves.
Yes. I wasn't holding it far away, far enough away from my face so I could see it correctly.
Where's the glasses?
I just laid it back there again. So this one is 30.27.
And that's for the population. if
That
you
would
guys-
be the population. If it was a population, then that's our standard deviation. What's N tell us?
The
Number
number
of,
of
how many
data,
there
how
are.
much data.
How many there were in the list that we put in there, how many pieces of data?
Oh,
We can scroll on down.
I missed one.
You missed one?
Yeah.
If we scroll on down, then it tells us min x, what's that tell you?
Minimum.
That's the lowest number in the set. This is what we're gonna do today. It tells us the median, but it also tells us this, Q1, then it says median, then it says Q3. What it does, it takes the data, it takes that whole list of data, and it splits it up into 4 parts. If I have a board, I got this board at my house, and I'm trying to cut that board into 4 parts, how many times do I have to cut it? 3. All right, so these 3 numbers are the 3 things that we're looking at for this. This is quartile 1. This is quartile 3. And the median is the same as what? Quartile 2. So it's just taking 3 numbers from the set and splitting up all the data so that 25% of the data is in that box, 25% is in that box, 25% is in that part, and 25% is in that part. That's why they're called quartiles. So if we scroll on down, then it's got the max, the highest number in the set. What's the one thing that it didn't give us on this? It gave us this. Oh, I'm sorry, I forgot the median. What was the median? 105.
Did they give us the mean? Or,
It gave us the mean,
oh, it gave us the mean,
gave us the median, did it give us the variance? No, it gave us the standard deviation, but it didn't give us the variance. So somehow we gotta find the variance.
I could put variance in the equation, you wanna get.
How do you find the variance? This is where a lot of people mess up.
You take that total, 3,058, and then take 30 minus 1, right?
So we could go back through and do the whole chart again, but if we're doing it on the calculator, if you're doing it using the chart, you find the variance first, and then you take the square root to get the standard deviation. If we're using the calculator, it tells us the standard deviation, so we're just going backwards. What would we have to do to this number to find the variance? Square it. So you take 30.78 and square it, if you're using the calculator. But again, a lot of people mess up, a lot of students mess up there because they get them confused. And they'll do 1 if they're doing the chart and mess it up, or whichever. You gotta remember that if you're using the calculator to find the variance, you gotta square that number. If you're doing the chart, you gotta take the square root to find the standard deviation. Think you can handle all that?
Yeah.
Cody, you can handle all that, it's easy stuff.
It's light work.
Alright, title for today's notes, measures of position.
Let me tell you then.
Measures of position.
Tell you then.
What?
I need to grade.
I wouldn't put them on this line weeks anyway.
What?
Oh,
What
try
are
it.
those? Which one? This Friday or next Friday?
That's right.
Well,
So we talked about
what's that thing for?
measures of central tendency, that's the middle of the data. We talked about stuff like the range, where we're dealing with how it's spread out. Now measures of position talks about different locations throughout the data. How to find the first, second quartiles, we just talked about that, we're going to talk about it some more. How to find interquartile range, represent data. And again, I wouldn't write all this down, just write measures of position. Just dealing with different spots throughout the data. Like if we're looking at this number line here that I have drawn over here, we're just looking at different numbers that fall like maybe here, or here. Just some position of each set of data. Find the interquartile range. That's going to be a big thing today. Be able to draw a box and whisker plot. They're not real hard to draw once you understand what information you need. Fractiles. We're not going to do a whole lot with fractiles. Well, we will do with fractiles. Fractiles is like all of them. Percentiles we're going to deal with. Quartiles we're going to deal with. There's another one that we're not going to deal with. And probably the most important thing today, z-scores. Z-scores are probably the most important part of a whole bunch of this stuff that we're doing. This I would write down. When I had Joe Armstrong in class, I enjoyed it because he, for some reason, I don't know why, but this stuck in his head. And every time we would talk about it, he would yell it out. You guys probably don't even remember Joe, do you?
No, we remember that screaming Joe on the sidelines.
Every time I'd say, okay, what's true about this piece of data? Boy, he was on it.
Yeah, we did kind of argument about global warming on the bus.
You always get in trouble with basketball games for screaming.
And it wasn't like, yeah, it was high pitch. Like an 8-year-old screaming.
So when we're looking at this is our normal, just our normal graph every time. It doesn't have to be the bell curve, it doesn't have to be all that, it doesn't have to fit the empirical rule or Chebyshev's rule or anything else. But we're always setting it up this way with the mean right in the middle, then you go out 3 standard deviations on each side. Anything that falls more than 2 standard deviations from the mean, so anything that falls from here out or here out is considered unusual. Anything that falls from here out or from here out is considered very unusual. So again, we're talking about positions of different pieces of data. So for data to fall in either of those 2 positions, it's either unusual or very unusual. So from 2 to 3 here, that data is considered unusual. And from 3 on out, it's considered very unusual. Fractiles, if I can get rid of some of this. Fractiles are numbers that partition or divide an ordered data set into equal parts. Median is a fractile. We've already dealt with that. Median's right in the middle. It takes the set of data and it splits it up into parts. Quartiles goes like this. I'm going to put all these up here. On quartiles, you have the first quartile, which is Q1, Q sub 1. And it's a quarter of the data fall at or below that number. Quartile 2, half the data falls at or below that number. And quartile 3, 3/4 or 75% of the data falls at or below that number. So if we're looking at these numbers, I just made a list up here. If this is our data, to find these quartiles, what we're going to do, first thing we probably find is the median, just because it's easy. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 pieces of data. We split that in half, that's 5. So 5 on this end, 5 on that end. The median would be right here at 5.5. And that's quartile 2. That's the median or quartile 2. Then we look at the data below that, and we got 1, 2, 3, 4, 5 pieces of data down there, and we find the median for just that part. Well, there's 2 here, 2 there, so 3 would be the median for that lower set of data. That's considered quartile 1. Then we do the same thing for the upper set of data, and we figure out that 8 is going to be the median of that set, and that's quartile 3. So now what we've done is we've split this data up into 4 parts. That part, that's quartile 1, or that's at or below that. Quartile 2, quartile 3, and then, I shouldn't say it that way, I'm saying it wrong. But we're splitting it up so that there's a 4th here, a 4th here, a 4th here, and a 4th there. Even though it doesn't come out quite right, because there's 3 numbers in one, but it's close to 25% in each one. That's all quartiles do. Splits it up into 4 parts. So just looking at this example, if we had this big long list, number of nuclear power plants in the top 15 nuclear power producing countries in the world are listed. Find the first, second, third quartiles of the data set. First thing you got to do with it is you got to put it in order. So when we put it in order, I thought I could pull it up here, just putting it in order, but apparently not. We put it in order. Then we find quartile 2, which again is the median. Find that middle number. Then you're going to take the numbers on the bottom, numbers on top. Here there's 1, 2, 3, 4, 5, 6, 7. So 3, 3, that number there is gonna be where quartile 1 is. On the other end, 1, 2, 3, 4, 5, 6, 7, so 3 down here, 3 up here, that's gonna be where quartile 3 is. You're just taking the data and you're splitting it up into 4 parts. 1, 2, 3, 4, and in each of those parts should be 25% of the data. If we did it on a calculator, we just did it earlier. If you put it into a list, it's right there. It shows you the median when you do that 1 bar stats. All right, so you can find it that way also. So if you were to put this into a list. Before I go on, what's one problem with this set of numbers? Look at this set of data.
There's, it's really like the one before.
Is it,
What about the 104?
it's a big outlier.
Okay, that's an outlier. Not only probably, maybe not even just the 104, but we look at all these numbers.
Yeah, the 50s too.
These two here are pretty far out there also. So that's going to change things. It doesn't affect quartiles as much as it did like the mean or the X bar. Interquartile range. This is important. So you might want to make sure you understand this as I go over it. It's not very hard, but seems to be everybody always forgets it. Yeah, it went up on my pen. There it goes. That's not what I want. Interquartile range, the IQR, is just that little formula there. It's not really hard. You take quartile 3 minus quartile 1. That gives you that range. So if you're looking at the interquartile range, what you're looking at is this data in here. What should be true about that data? Should be how much of the entire data? Should be half, should be 50%. So the interquartile range should be half of all of the data for 50%. Well, it's, no, because median tells you that half of the data is from here down.
Okay,
The interquartile range is dealing with
the ones
in the middle there. How much of the data is going to be over here?
25%.
And how much over here? So if we're going to find the interquartile range for this, we just take quartile 3 minus quartile 1, 31 minus 10 is 21. So that's the interquartile range. Nothing really hard about it, it's just, again, it's something that, using the interquartile range to identify outliers. You can find outliers in a set of data by using these two formulas. So if we use those two formulas, it tells us if a number is going to be considered an outlier or not. And I'll show you here in just a second. Hoping I did that right, is that, I don't remember from the last couple of slides, but it was 10 quartile 1 and 18 quartile 2 and 31 quartile 3.
Yeah, because we did 31 last
So if we're gonna do this formula on this, quartile 1 is 10 minus 1.5 times the interquartile range. Interquartile range is gonna be quartile 3 minus quartile 1, so 31 minus 10, which was just 21. Somebody help me out, punch that all into your calculator. You can punch it in just like it is right there. Negative what? 21.5.
I have a question.
Yep.
How'd you get quartile 3 as 31?
So this number right here, this is the median, quartile 2.
Yeah.
So then we look at all the numbers above that. There's 1, 2, 3, 4, 5, 6, 7 of them. And we're just finding the median again of that part of the
Oh, so the
data.
quartiles are just the medians between these things?
Right.
Okay.
So this is like the median of the lower numbers. This is the median of the upper numbers. Quartile 3 here is 31 plus 1.5 times interquartile range, which we said was 21. Somebody do that for us. 62.5.
Yeah. There, right.
So all these numbers are telling us anything lower than that number right there on our list would be considered an outlier. Do we have anything that's anywhere close to being lower than that? That's a negative number. It's way down here somewhere. We're not anywhere close. Anything that's higher than this number would be considered an outlier. Do we have any numbers that are higher than that?
Yeah,
Yeah. So what do we know about 104?
it's an outlier.
It's an outlier. Now, you look, 62.5, 59 is really close to that, so 59 is close to being an outlier, even though it's not considered an outlier. It's close to being way out there. It's almost higher than 62.5. Sometimes with outliers, sometimes we'll just like get rid of them or something, if it depends on our data and what we're trying to do. I'm not telling you to get rid of them all the time, that's not the case, but sometimes. Box and whisker plot. Box and whisker plot is just a way to analyze data. I would write down a box and whisker plot, and I would write down this. 5-number summary. You got to know these 5 numbers to make a box and whisker plot. Where are we going to be able to get those 5 numbers from?
They're all on the calculator.
Yeah.
All of them are on the calculator if you put the data into a list. Why is it called a 5-number summary?
Means 500.
Math people are very creative. So we need to know the minimum, maximum, quartile 1, quartile 2, and quartile 3. From all that, we're going to be able to draw a box and whisker plot. Has anybody ever seen a box and whisker plot before?
Yes.
Like 2 boxes right on.
Nothing really hard. I'm going to show you the easiest way to draw one, and then we'll have got it left on
I
there.
remember doing that like a long time ago.
use box and whisker plots a lot on stuff like standardized tests and everything. Right, so drawing a box and whisker plot. Find the 5-number summary. I'm going to go through this sort of quickly because I don't think you really need to write all this down. I think you'll be able to handle it. Plot the 5 numbers on a horizontal scale. I'm going to show you how to do it. Draw a box above the horizontal scale for quartile 1, quartile 3, so on. Draw a vertical line, quartile 2. Draw the whiskers going out to the maximum and the minimum. And it's going to look something like this. Notice here, when you have this long whisker, what's that telling us about 104 out there?
It's a really big outline.
All right, so if we were drawing this box and whisker plot instead of putting this out here, I would probably put 59, stop my whisker right there, and then put like an asterisk out here to show that that's 104 as an outlier and not put in that part of the whisker. Let's see. Let's go back for a second. We make up a set of numbers just to show you how to draw a box and whisker plot real quick. Nothing hard about it. Don't make it harder than it is. Let's make up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. That's our set of numbers. You need to find 5 things. You need the minimum. What is the minimum this time? You need the maximum. What's it? And then you need your 3 quartiles. Quartile 1, quartile 2, quartile 3. Find quartile 2 first, the median. We got 10 numbers, so we go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So quartile 2 is somewhere right there, which is going to be 5.5. Remember, to find that median, you add those 2 together and divide by 2. Quartile 1, you got 5 numbers down here. 2 on this side, 2 on this side, so what's quartile 1?
3.
And quartile 3, 5 numbers over here, you got 2 here, 2 here, what's quartile 3?
8.
Then to draw our box and whisker plot, first thing you're going to do, draw a number line. Put our numbers on it. This time we can probably just put our numbers on it. If you don't want to draw a whole lot or something, let's say you want to do it this way. You want to go like, maybe something like that, I don't know, just whatever. All right, but put the numbers on there. Don't dumb it down so much that I can't tell what it is. Then, this is the way to draw your box and whisker. First thing I'm going to do is put a point at my minimum. Put a point at the maximum. Then these 3 quartiles, I'm going to draw a bar for each one of those. So I'm going to come here to 3, I'm going to draw a bar. I'm going to go to 5.5, draw a bar. I'm going to go to 8, draw a bar. So I got my 2 dots and 3 bars. Then all you're going to do, make it into a box, connect your whiskers to the box. That's your box and whisker. On a box and whisker, what's true about this box right here? Just this box. 25% of the data. What's true about this whisker out here?
25%.
25% of the data. What's true about this box?
25%.
What's true about this whisker? What's this called? From here to there?
Oh, did we just, enter,
Interquartile range.
Yeah.
And what do we know about inside this whole box?
It's 50%.
50% of the data.
What would you use this for?
I just told you they do it a lot for like ACT scores and stuff like that.
Ooh, I'm in the outliers
That's my bad.
range.
You're out. You're out here, Riley.
Oh,
The other side?
the other side. Well, yeah, that, if we're using that.
So on this, I'm going to tell you what to write down on this here in a second. Quartiles we just did, so you really don't have to write that. It divides it up into 4 parts. We're not going to do deciles, but know it. Deciles divides the information up into 10 equal parts. Percentiles divide it up into 100. That part you probably do need to write down. Notice quartiles is Q with a subscript. Percentiles, P with a subscript. So if I write down something like P 25, that's saying the 25th percentile. Guarantee when we take a definitions or a, not a definition, that's geometry. When we take a symbols quiz here real soon, this is going to be one of the things on there. I'm going to put something on here like this, P17, and you're going to have to know that, hey, that means the 17th percentile. So quartiles and percentiles are the ones that we're going to deal with. We're not going to deal with deciles. Now the book might deal with it a little bit, this section, but nothing after that really. What do you think's true? Let's talk about percentiles here. What do you think's true about if we're at percentile 17? What's that tell us? 17% of out of 100. So what that's telling you is 17% of the data falls at or below that certain number. So if you're at the 17th percentile on a test, is that good or bad? Not very good, because 17% of the people scored lower than you. Well, that means that 83% scored higher than you.
Let's go back to the same grade.
Does anybody remember what this graph was called again?
Something dot.
An
Ogive.
Right, with an ogive. Remember, an ogive takes you up till you get everything, every piece of data counted. So it's saying, you know, at this point there was this many, at this point this many, here or below. This point there was this many here or below, so on and so on. This represents cumulative frequency distribution of SAT test scores of college-bound students in a recent year. What test score represents the 62nd percentile?
Like 60.
So 62nd percentile. How are we going to figure that out?
You go to 60. You go to the percentile up there at 60, a little bit above 60.
So somewhere just a little bit above this, and we come across here, and we hit it somewhere about in there. So what do we need to do? Go straight down, see what we're at.
So 1600.
Let's see. This is
1600s.
that's 900. That'd be 1,000, 1,100, 1,200, 13, 14, 15. So about 1,600. Maybe a little less than 1,600. All right. So what's that? Let's interpret that. What's that mean?
You got
If your score was a 1,600, what's that telling you?
that's pretty good. You scored higher.
You scored higher than,
62%.
so your score is higher than 62% of all of the other scores. So you're on the upper half.
Oh, maybe 16.
Go Isaac.
I didn't even get at least test either.
Percentiles used to compare scores above the 95th percentile. This you might want to write down, above the 95th percentile and below the 5th percentile, considered unusual. As long as you can interpret the rest of it, 78th percentile means that that piece of data is higher than 78% of all the other data.
Why don't we take the SAT anymore? Why don't we take like the ACT?
Most colleges decided that's what they wanted.
You don't need it.
Yeah, so
We even did the ACT.
that's,
A lot of colleges are.
didn't you guys take the PSAT in
Yeah,
here? See, I don't understand why we're still doing that if,
I think we did.
yeah, I know most, as juniors, usually most people take the PSAT in high school,
And then take the SAT or the
ACT and the-
ACT, yeah.
which that, yeah,
Why do you
doesn't
say
make any
60?
sense.
Well, a lot of colleges
No.
So 95 percentile, 95% or higher, considered unusual, 5% lower, considered unusual.
don't. What?
Again, this is used to compare scores, so they use this on like the SAT, ACT, to compare everybody's scores across the country. A standard score, this is probably the most important thing of the day. A Z-score. A Z-score is a standard score, represents a number of standard deviations a given value falls from the mean. And I put mu in here, that could also be X bar, depending on if we're dealing with a population or a sample. What a standard score is, and Z-score is not the only standard score, but that's one that we're going to deal with for now. What a standard score is it takes all the scores and it makes them into some standard score so that you can compare scores for anything. So it could be that you take a English test and you take a science test. Well, you can't compare the English and the science test because they're two completely different things. But if we turn them all into a Z-score or a standard score, then we can compare. How did you do on the English test compared to how did you do on the science test? To find the Z-score, you use this formula. Z equals the value, that's that score, whichever score you're dealing with, minus the mean, divided by a standard deviation. Instead of mu here, what else could it be?
X.
X bar. Instead of sigma here, what else could it be?
S.
S if we were dealing with a
Same.
sample. I may have that up here. I don't know. Nope. Previous. Oh, maybe I had two different formulas. Stuff that we've covered this year. This is probably one of the top 5 most important things. Finding Z-scores.
Z-score? See that breaks down again? Cold breeze. It's crazy.
Braves and Red Sox.
You. Oh, I got yours.
In 2009, Heath Ledger, sorry that this is old. Does anybody know who Heath Ledger is? You
He
do?
must have played in the
He
Batman.
played
yeah.
Joker.
Is it he the one that was Joker?
Yeah.
For Best Supporting Actor at age 29, his role in the movie The Dark Knight. Penelope Cruz won the Oscar for Best Supporting Actress at age 34 for her role in Vicky Cristina Barcelona. The mean age of all Best Supporting Actor winners is 49.5. All right. With a standard deviation of 13.8. The mean age for all Best Supporting Actress winners is 39.9 with a standard deviation of 14.0. Find the Z-score that corresponds to the ages of Ledger and Cruz, then compare their results. So we're going to find these Z-scores because we can't really compare Best Supporting Actor to Best Supporting Actress, because we all know that there's sort of a double standard in our world where once a lady gets older, probably not considered quite as good looking, right? That's just the way it goes. I'm not trying to be a sexist here, but that's the way our world is, right? When a man gets older, unless he gets like Ebersole and fat and out of shape and stuff, as a man gets older,
He looked better.
he probably looks better. He's more distinguished and more, so two different things.
Jennifer Aniston just built different.
So for Heath Ledger, I put all these numbers in there and I found his Z-score. His Z-score was negative 1.49. For Penelope Cruz, hers was negative 0.42. Standard, so 0.42 standard deviations below the mean. And we're going to compare them. Looking at this, Heath fell right in here somewhere. Penelope fell right in here somewhere. So, which one was more unusual? Heath, because he was farther away from the mean. The other thing that I would write down there somewhere was Z-scores. Write this down, that's 0. This is like our little chart, just like we had the chart with the standard deviations. But when we put stuff in Z-scores, the mean here is always going to be 0. This number is just 1 because it stands for 1 standard deviation above, 2 standard deviations above, 3 standard deviations above. And then these down here is going to be -1, -2, -3. So that's our little number line that we're going to use like we were using with the other scores, but this is if we change them all into Z-scores. If we changed everything into a Z-score. A little easier to deal with because we don't have all the decimals and all the other crazy stuff on there, and I don't have to have Isaac tell me what 79.1 minus 15.6 is and all that stuff.
What is it?
We did it earlier. Weren't you paying attention then either?
Nah.
All right.
At least you're honest. At least you're honest.
Yeah, at least I'm being honest. I'm just kidding. I just don't remember.
The assignment's on page 107.